implement PID controller. So we know that generally the controller is mainly used for rectification or reducing the error. So generally P controller, I controller, derivative controller. So by using this P controller, generally the P controller is used to improve the response of the system, whereas the integral controller is used to reduce the steady state error to zero value, whereas the D controller is used to improve the transient response. So by combining P plus I plus D, that is P controller, integral controller and then derivative controller. By using these three derivative controllers, mainly it improves the transient response. Just like the transient response is nothing but improving the reducing the peak overshoot and reducing the settling time. That is a PID controller application. Now if you take a second order system, we know that a second order system is nothing but it is having the order of 2. Generally the time constant is generally first order is 1 plus st1 and then 1 by 1 plus st2. Now so if that value is giving input to the PID controller, then it modifies and reduces the error. So coming to the waveform. So this is the waveform what we are getting by using the PID controller. So from this we can calculate the peak overshoot and steady state value. So peak overshoot nothing but it is the peak to peak value, and steady state error is we can calculate it by steady state to steady state. So by finding these two, peak overshoot and steady state, you can calculate the peak overshoot, that percentage peak overshoot and percentage steady state error by using this formula. Now so we know that x is the 2 into steady state values, means whatever the steady state from this point to this, that is y-axis distance from this point to this point. Similarly peak overshoot is from peak to peak, distance from peak to peak, that we have tabulated in y and x. So x is the steady state, y is the peak to peak value. Now from this two you can calculate a steady state error as peak to peak input minus steady state by peak to peak. Similarly peak percentage overshoot is nothing but it is the peak to peak input minus steady state by steady state into 100. So the application of PID controller is mainly it improves the transient response. If you use the different controllers differently, that is P, I and D, by accumulating these three P plus I plus D, it mainly used the controller mainly used for improving the transient response.